Welcome back, future elementary educators. Let's talk about circles. Let's talk about circumference. Let's talk about arc length. Um, Mathematicians studied this problem a long time. Here's a circle. It's got some radius and it's got some diameter, but it's got a radius. And the thought was, what's the relationship between how big the radius is and how big the distance is all the way around? So back when they had a lot more spare time, because Netflix and Hulu and Amazon had not been invented yet, people would actually measure the circumference of a circle and measure the diameter of the circle, right? The diameter is the distance all the way apart, all the way from one side to the other through the center. And they would divide the circumference by the diameter, and they'd always get some number that was approximately 3.14159.265. And I mean, depending on how accurately they were able to measure, they were able to get better and better estimates. They decided that this number that always popped up, no matter how big they made the circle, deserved a name. And so that name is pi. And so we now know that the circumference of a circle is pi times its diameter. This is something that little kids learn, that bigger kids are reminded of, and that teachers look up when they need to know it. The circumference of a circle is pi times its diameter. If you can measure the diameter all the way across, then you can know how far the circle goes all the way around. If you know how far the circle goes all the way around, then you know how far the circle is across from one end to the other. Pi is an irrational number. It goes on and on forever and ever without ever repeating. So when the Einstein bobblehead doll in Night at the Museum 2 says pi 3.14159.265 to be exact, the Einstein bobblehead doll is wrong. There are lots of decimal places after 3.14159.265. It is not exact. It's darn close for our purposes. I mean, the places after that 5 don't greatly change computations, but it's not exact, and you should know that. So we can do this thing where, like, we want to know, we have some lake, it's a circular lake, and we want to know how far it is from one side of the lake to the other, because here's somebody's house, and here's some other buddy's house, and we want to know about how far that is. But you can't measure across the lake, right? Because if you try to measure across the lake, you don't have you could just drown. So instead, we measure all the way around the lake. We can do that. And let's pretend that it's 2,021 feet all the way around. Well, that circumference, that 2,021 feet, is pi times the diameter, the distance across the lake. So if we want the diameter, that's 2,021 divided by pi, whatever that turns out to be. 2,021 divided by pi, do you have an estimate? Take 2,021 divided by 3-ish in your head. What do you get? Well, that diameter is approximately 643 feet wide. And we're able to indirectly measure the distance across the lake without having to drag out some tape measure in a rowboat and measure across the lake. Well, what if you don't want to go all the way around the circle? Like, what if you have some circle and you only want to measure like this much, like 120 degrees. You just want to know what this part is, and you happen to know that the radius of the circle is 10 centimeters. Could we find out just how long this red fuzzy arc is? And the answer is sure you can. This is the measurement of an arc. This is a length of an arc. If we went all the way around, the circumference of the circle is pi times the diameter. Now, what's the diameter? It's twice this, right? It's this. So we don't want the whole circumference. We want this part. So the question is, what part of the circumference is the red fuzzy arc? Pause for a moment. Ask yourself, what part of the circumference is this arc? Well, I hope you thought to yourself, there's 120 degrees in that central angle. There's 360 degrees all the way around. That's 1/3 of the circumference. And so the arc length is 1/3 of this 20 pi. That's the arc. Oh, whoa, I'm so sorry. That, I'm so sorry. That's the arc length. It's 1/3 of the circumference. Nothing special about 120. If this angle is some other number, we just stick that other number here. The fraction reduces and we multiply by the circumference. There's nothing fancy here. Not at all. Because linear measures are proportional, we can use a proportional reasoning to figure out any arc length on a circle if we know what the central angle is. And I hope that's helpful, and I hope that this screencast tides you over until we can gather in class and talk more deeply. See you then.